Alright, let's talk about osteopetrosis. Osteo means bone, petrosis refers to rock-like. So this is a disorder in which you have abnormally thick, heavy bones. It's an inherited defect in bone resorption. Now, if you remember, bone formation is a balance between osteoblasts, which lay on bone, and osteoclasts, which resorb bone. Now, this balance is constantly occurring throughout life so that you're always laying down some bone and always resorbing some bone. Now, a defect in bone resorption in which you're constantly laying down bone and laying down bone but can't resorb it results in an abnormally thick and heavy bone. Now, despite it being abnormally thick and heavy, it fractures easily. Think of it like a piece of chalk. A piece of chalk is thick, but you can easily crack it. Now, this disorder is due to poor osteoclast function. It has multiple genetic variants. Most important is the carbonic anhydrase 2 mutation, which results in a lack of acidic environment that's required for bone resorption. An acidic environment is necessary in order to remove calcium to resorb bone. Now, in order to generate an acidic environment, the enzyme carbonic anhydrase is necessary. Carbonic anhydrase combines water and CO2 to make up H2CO3. Carbonic acid then breaks up into a proton and bicarbonate. Now, this proton, which is the acid, leaves the cells, and this is what creates the acidic environment necessary for bone resorption. If osteoclasts don't have the ability to generate this acidic environment, they won't be able to resorb bone, and this is exactly what occurs in the carbonic anhydrase 2 mutation. The clinical features of osteopetrosis include bone fractures. Now remember, although the bone is thick, it's going to be very weak, hence it's more prone to fractures. And this is because there is no proper balance between the osteoclasts and osteoblasts. And in order to make strong bones, you need to have a balance between the osteoclasts and osteoblasts. Patients can also have anemia, thrombocytopenia, and leukopenia. So now this occurs because the thickening of the bone replaces the medullary space, which is called a myelophysic process. Myelophysic process which knocks out the ability for hematopoiesis. Hematopoiesis, which means generating blood cells. So if hematopoiesis is knocked out, individuals end up with anemia, low red blood cells, thrombocytopenia, low platelets, and leukopenia, low white blood cells. These individuals end up with extramedullary hematopoiesis, so this blood cells are going to be made outside of the bone marrow, either in